Masterson. I'm one of the automation specialists with the Reynolds company here in Houston. And today's users group, I do thank everyone who's attending today. We're talking about computing on the edge. So we're going to look at the compute module and the new edge gateway. Niraj, I believe you're driving the screens. I will be acting as one of the panelists, but we also have 4 or 5 other people who are behind me to assist me as you might ask questions. We have Chris Dornan with Rockwell Automation, who's a large marketing manager for large controllers. And Niraj, someone said I was going to butcher his name, Kuchachdia. Niraj, how do you pronounce your last name?
Hey, Kachadia, Niraj Kachadia.
Well, I got about 70% of the way there. Who is the business lead in architecture and software components for Rockwell out of the DFW area. And let's go. Oh, we will be recording this and posting it on our website. I want to make you all aware of that. I want to take a look at some upcoming events we will be having. If everything works out, we will be talking about Plant PAX 5.0 on September 17th. That might be subject to change because it might be we might be talking about it 2 weeks before it actually comes out. But for right now, we do have Plant PAX discussion on September 17th. And then next week, we're going to be having one of our tech talks, so a little bit less involved, but we're going to be going over Innovation Suite and the ThingWorks platform. And one more slide, Niraj, before you take over. Most importantly, Automation Fair is coming up November 16th through 20th. It will be an all online automation fair. It will not be an in-person session this year. So I want to make you aware, we will have access to labs, and registration, more importantly, will be starting up in September. So we want to make you aware of it now so you can start planning for it, because there will be labs available. They will be online, and we would like our customers to get signed up as soon as possible. So we will keep pressing the issue and making sure you're aware of when registration is open. And when we get an exact date, we'll let you know. And with that, I will hand it over to Niraj.
Hey, thank you, Mike. Good morning, everyone. Welcome to the Scalable Compute and Edge, FactoryTalk Edge Gateway user group. So with me today, we have Chris Dornan, who is marketing manager for large controllers, large control systems, and large controllers, safety controllers as well. And we are going to talk about Scalable Compute module, and he will lead the conversation on Scalable Compute. But Chris?
Great. Hey, thanks, Niraj. Did you want to speak towards this kind of piece here before I get started on this slide?
Okay. So today's key requirements in the market today is the high-speed and synchronous data collection, which plays into what the software is undergoing. The software market and the software products are being modularized so that they can be installed and implemented at the edge. What the Scalable Compute module and the software, the edge gateway, together comprise a single box configuration, which is highly required and requested by today's IT teams, right? It also, today's requirement is the time to value, right? How fast can we implement a system for today's OT and IT environment, plus how much less engineering time or IT knowledge is required to configure those software module, and how fast the customers receive the value of that investment that they have done. It also provides, and today there is also a requirement about the way we interface with the IIoT platforms, right? The requirement is that the integration should be simple and easy to maintain over a long period of time. These are the key requirements today. So we will talk about how we can address those key requirements with our scalable compute module and Edge Gateway software, FactoryTalk Edge Gateway.
You know, what's interesting there as well, Niraj, is I think the one point you made on the last one is that the customers change for even white box PCs. And I think one thing we've seen, and I'd be interested to hear from this group, is a lot of plants are removing those from the plant floor for cybersecurity concerns, et cetera. Are you guys seeing much of that? Are you seeing the request to pull PCs out?
Yes, they are going towards more smaller thin clients, because they would not want to risk on the plant floor with an Windows OS PC being open to any devices, plug-in USB, or talking to internet. That's correct.
Sure. Yeah, I think one important thing there is it's what we've seen as well. I think one of the things from the hardware piece that'll be important when we present this today is what the Scalable Compute platform is meant to do is a lot of things that Niraj said on the first slide. An important piece is that it continues to offer PC capability to the plant floor, knowing that there's the IT-OT convergence and knowing that, you know, depending on the relationship that you have with the IT department, it may be a place where you can take advantage of things where you have an OS, but not in a white box PC. And that OS can be, you know, in a compute module that's right next to, say, a 1756 controller in the 1756 chassis, a computer in the rack, if you will. And we'll talk a little bit about the difference between that and the CompactLogix 5480, which actually is taking advantage of an Intel i7 chip, which has 4 cores, and one of the cores is an OS. That proximity allows for high speed and the fidelity of speed in terms of, say, much more stringent applications that need that. A lot of times you see that with like camera and the amount of the speed of a conveyance that a camera is trying to get information quickly, a lot of information fast. There's a lot of things that happen between that and so forth like that. So, you know, the port I'm going to go to is really talking about the hardware, but I think what's going to jive well with how Niraj follows up is this hardware gives us a lot of capability for digital engineering, for analytics, et cetera. And so that marriage of software, the appropriate software on the hardware is important. That PC being, yeah, go ahead, Niraj.
So I was going to ask that you brought up a very good point. We have a different portfolio here, and with the PC Scalable Compute and the 5480, how and this would probably flow well with the different applications, right, Chris?
Definitely, and it's actually a little bit. If you look in history too, you know, we've had 1 and 2 and now 3 kind of options here. One thing I think we take for granted is our industrial PC line, a lot of the visualization hardware. Now that whole group is changing. I think you guys all know that the awesome, I think that's how it's pronounced. I like to call it awesome, right? I wish we could use it. The awesome portfolio of additional PCs, or, you know, PCs in a box, if you will. But the capability of marrying an OS with an HMI client has been around for a while. So that capability, taking advantage of Thin Manager, et cetera, has been part of the Scalable Compute portfolio, really was the first option, if you think about it. And again, marrying the HMI client to a PC, whereas the next two, both the compute module as well as the CompactLogix 5480, are marrying a PC with Logix. So the difference here is the compute module, and it actually has been offered for a good amount of years now. I know that Oldie, I don't know if it was Softing at the time, and some of our partners have offered the computer in a rack. You know, and this kind of takes that same piece to allow you to have a PC within the rack. Now, the one big difference between this and the CompactLogix 5480 is how the PC interrogates Logix. For the compute module in the middle here, it actually uses a built-in API that actually interrogates through the backplane into the Logix processor, and it has access to, I think, about 40 instructions natively to Logix. So in terms of kind of creating a custom application that, say, marries the power of Logix with maybe you want to do something in Python or C++ or Java, it allows you to kind of bring a PC computing element to really develop kind of complex algorithms, complex logic, if you will. A lot of people do work with MATLAB, for example, that want to interface some of that knowledge into, say, the control algorithm, and you can do that. And that marriage of not only software, but being able to create unique, say, control algorithms by interfacing directly with the backplane into the Logix API is pretty important. The difference between that and the 5480 is actually the 5480 uses the virtual backplane to pass information back and forth. It is looked at and discussed about adding API capability to the CompactLogix 5480 as well, but no timing on that yet. And as we talked about before, it is an i7 chip, 4 cores, 3 for Logix, 1 for the Windows 10 IoT Enterprise OS, which I know we'll talk about here in a little bit. And I think also to address Niraj's question is a slide like this that said, okay, well, maybe there's 3 different use cases, and these aren't all of them. But if we start from the left and say, well, I want to embed a custom application on an OS, and I don't want to have a white box PC because I don't get along well with my IT department. And another thing about that is, how do I reduce the target area for cybersecurity? A white box PC probably has not only a firewall, but switches, managed switches, lengths of cable, etc. That's a pretty large target area for attack. When you move that PC closer to even within the rack or part of the product, you remove all of that extra, if you will, extra hardware sometimes that could be very important. So, and I want to use all that. I want to get the information faster to feed the software, and the faster I can do that, the better. And that's when you look at, if you click one time there, Niraj, that's where the compute module, I think, still plays the best. The middle one is highlighting the fact, well, really, I just need an HMI that shows content from various devices and applications. So similar to things we have in our own houses, like you know, the switches, so we can play a show not only on our TV, but on our PlayStation 3, etc. This is where the VersaView, this is one of the industrial computer components by our visualization hardware team. And a lot of this is actually married with Thin Manager to begin with. And this would be probably the optimum piece to buy if you're hosting a lot of Thin Manager sessions and Thin Manager clients. Last but not least, well, I need something that maybe was built for high demand motion, and we'll talk a little bit about that when we define the, as you'll see here, and you go forward here, Niraj, is the 5480. But maybe I need to have a small version or a low version of Studio 5000, maybe a maintenance version on the same PC so that I can hook up right to it and be able to do things and have it all be in one place. A lot of OEMs, how do we enable OEM footprints with a product that has Logix and a PC married in one product? This is a lot of work. A lot of people knew this as the work of the EPIC chipset. And this actually controller has been in the works for about 6 years, really. And interesting life cycle. It was originally built for, you know, you look at motion applications that were over 100 axis per millisecond. Don't see a lot of those today, and a lot of those require functional safety, which we'll see here in a little bit. But we also decided that we'd take advantage of the 4 cores to put an OS on one of them. And so that really differentiated how we could go to market with the product. The one thing you see that we had to learn pretty fast, though, is that if we were going to sell a motion controller at a motion controller price to an area where some people are using Raspberry Pis, we had to be in the right pricing ballpark, which is why you'll see in a couple slides that we created some scalable options for the 5480 as well. So with that being said, just a little bit more detail about the options within the Scalable Compute portfolio. Again, this is the compute module in the 1756 chassis. We talked about the built-in API. It does have another Intel chip. This is a dual-core chip, and 4 gigs of RAM, 32 gigs SSD. Actually has about 20 gigs of free space for applications. Based on the customer set that you're looking at, this is always a good option if you have a customer that's or you yourself have already standardized on 1756 on ControlLogix. You have an open spot in the rack, and basically, again, this talks over the backplane for very fast communication using that API to interrogate the Logix controller. It does actually have two options compared to the 5480 as well. Right now, the 5480 only has as an OS choice the Windows 10 IoT, whereas the compute module, you can choose the Windows 10 IoT or Linux. Now that Linux is 32-bit, I believe, right now. We are discussing and hoping to have within FY21 a version that offers 64-bit Linux as well. So that's some of the big things. If we go to the next slide again, Niraj here. The 5480, again, has a history of being built for, and still is a high-performance motion controller itself as well, because you look at 100 access per millisecond type of capability, it actually plays very well and sometimes can even beat the 5580 in terms of scan time improvement for motion applications. However, again, we'll see that I think more of the sweet spot is using this for again, a true scalable compute portfolio where you can have an OS marry either custom applications or embed certain software as a complete solution to be delivered out to it. And then for that case, we've already done some testing. Commercial engineering has done some testing that looks at performance of View clients as installing View on that device, and based on the HMI tags, performance on, opening up a faceplate based on the tags compared to a PC or compared to other product there. We've also used it as a historian interface, and we've also installed things like the Fin Manager. It's the WMC or something like that on the previous slide. I forgot already, a brain lock in terms of some of that.
Sorry.
I think I have it on a further slide here, Niraj, no problem. Now, again, I kind of alluded to the fact that we needed to create some new catalogs for this, because we originally came out with just a 20 meg version of Logix memory and priced it, in the 17 to 20,000 list price range, which again, for people that were looking to procure this for a scalable compute was just, price was a non-starter. So about the July summertime, we were able to release 4 versions of this that scaled on Logix memory. So you see, starting from the top to the bottom, 3 to 5 to 10 to 20 megabit here. Still having exactly the same Windows, the OS portion of it, but it could be for those that say, I don't need as much Logix, but I want to take advantage of a lower price. And this shaves maybe $10,000 off the list when you get down to the 3 megabit version, which allows us then to play in the scalable compute arena, which I think is important. And for our internal capabilities, there's a lot more links and capability for information on this as well. But this was important because I think this allowed us much more to play with the 5480 in the scalable compute space. Now you may ask, okay, what is this Windows 10 IoT Enterprise OS? And actually Rockwell worked with Microsoft. Microsoft is one of our partners from Rockwell. We have a dedicated team. If anybody knows some of the people up north, Chris Mason and team that work with Microsoft, they worked together on what was called this long-term service branch, or LTSB version. It's a specialized edition of Windows 10 Enterprise that was really built for the control room floor. It was built for industrial applications. That is because it really provided the longest interval before it expected you to upgrade the OS. It has security and stability updates that from the time, and I believe, starting in when this was released in 2016. So you're looking, still having a long viable life to at least 2026 with security and stability updates. And it doesn't have the things, like you can't compare this to the Windows that we're running on our own computers and PCs, what I'm running right now. You don't have things like the Store, Cortana, Edge browser. You don't have Solitaire, although I wish it would, right? Yeah. But it doesn't have those gaming. It doesn't have those applications that go out and require updates and have a connection out to the wild World Wide Web, et cetera, right? Doesn't have those applications that are not built for really the industrial space. So it is an OS that was built for the industrial plant floor, and we take advantage of it. Next slide, please. Yep. Go ahead, Niraj. Were you going to jump in there?
Yes, I was going to ask you. So from the scalable and edge computing, this slide really talks about what you have talked so far about how it reduces the footprint for the cyber attack by bringing down the application very close to the controller and removing the hardware that is required to apply and to deploy an application like camera anomaly detection
Sure.
with an Edge ML, right? And so on this application side, what other applications are critical that we can implement, right, with the 5480 controller and with Scalable Compute? We talked about the motion application, right? The motion application that you talked about. Can you give a little bit detail on that?
Sure. So, and again, we still feel that there's a large market out there, and maybe still to come a bit where that performance on a motion side is needed. Again, ballparking around 100 axis per millisecond with huge highest inline performance in terms of scan time. So, and again, our foray and history in terms of serving the automotive industry and so forth is key to where some of these applications may rely. Definitely not the only industry that we see this. Some of the biggest users are people like Tetra Pak and so forth. So you see places in the food and beverage space, CPG as well. But the one thing, as I alluded to before, typically those applications need to have a functional safety element and that kind of structure built in. And hindsight being 2020, I think there's other reasons. We could have thought maybe we should have built the 5480 using a compact ContactLogix, but we didn't. There was a lot of reasons for that. But the beauty is maybe you're putting the 5480 into an architecture that may already have an existing functional safety controller, whether that be a ContactLogix or a compact ContactLogix, or even taking advantage of like the CR30 that you see on the left, can be part of the architecture that allows you to have that functional safety along with the high performance motion. So, any times where you see that kind of access per millisecond, again, some of the things that you see at Tetra Pak, Solar has a few, and others where we've sold some of these for the motion aspect of it, it's still an important use case to know that we have and to serve out there. And again, the other things, and this is the big thing where I think, and I still have a call out to you, our users, our partners, we're just scratching the surface. If you even think this is comparable to, and if you guys know Joe Geigel, who is my counterpart for visualization hardware, we were even planning before COVID struck to do a lot of road shows where we would talk not only about, and try not to PowerPoint to death, which forgive me, I know I'm doing a little bit to you today, but looking at what are those unique use cases where this technology really shines. Because I think one part that I know I still struggle with is the technology sounds cool, but that really doesn't, it's like, unless we give you a value point or a use case where this has been done and the value brought, it doesn't play as well. So that's why internally we've done a lot of things in terms of looking at how, if you put view on that OS, what does that solution look like? Things like testing, and WinTMC was what the brain block I was having earlier. That's what we would test from the thin manager perspective there. I'm not going to steal Niraj's thunder, but we'll continue to ham and egg it as we start talking through the Edge Gateway product, et cetera. The one beauty of this is we've actually created a demo on a use case, and we're publishing the white paper now about using the Edge Gateway on the 5480 explicitly to create a communication protocol for OPC-UA. OPC-UA is, again, one of those prevalent networks that we're being requested every day to have that native to the hardware, which we are working on. But if we can create a solution where the Edge Gateway is installed on the 5480 and already have kind of it set up to talk OPC-UA, you can almost enable a native connection, if you will. We're still having a little bit behind the scenes to make that happen, but we think it's a good step forward to address a lot of conversations that ask us to how we connect to OPC-UA. A lot of that information that's already out there, it's on our knowledge base. And I know you guys will have these slides to refer to later, but that is the knowledge base answer that you can go to for, some of the testing positioning piece on the performance based on view on that OS as well there. So a lot of good things we're doing there, Niraj, but in some of the others, you saw in Perex, they were using a camera for anomaly detection and using the 5480. We've actually looked with some of our Encompass partners, one of them being Illumin, that does dashboards for OEM builders. So they've enabled kind of their workflow or their diagnostic package so that they kind of remote into all the machines and be able to, you know, preventatively diagnose problems, taking kind of that analytics piece to the next level there. And they've put that together with Logix on a 5480, marrying the PC with the Logix that way. There's so many other use cases that are being looked at. One is for serialization that we have some knowledge about and some slides about, but depending on what the requirement is, and this is just kind of a snowball rolling down the hill. And we think that the more use cases that people look at and find the value for this technology, there's going to continue to just build upon each other as we look at this as how we deploy it. And I know one thing that Niraj is going to talk about is exactly, you know, part of this of enabling that connection through the edge gateway to allow some really good uses there. And I think we're almost ready for that transition anyway. I wanted to set you up properly, Niraj.
Hey, thank you, Chris. You are correct. So when Chris was talking about how critical different software pieces that can be implemented on our scalable compute portfolio with 5480 and 1756 compute module, we see that customers like yourselves and our partners, they request the connectivity to the OT environment directly from, let's say, an IoT platform like ThingWorx. So a FactoryTalk Edge Gateway is that software piece that gives us the ability to connect and contextualize the data and then deliver that data to any to IoT platform like Azure IoT Hub or ThingWorx without any skill set required from an IT personnel or an IT department. And that is the benefit, that is the value, the big value. So what it is, what is FactoryTalk Edge Gateway? Well, FactoryTalk Edge Gateway is a software which actually empowers a controls engineer to deploy a solution that connects the IT and OT world, right? So you connect to the data that you require from the PLC, you contextualize it, you build a model, and you map it out to deliver it to the IoT platforms. And this also reduces your footprint that can be attacked from a cybersecurity perspective. So what are the data sources? When we talk about it connects to data sources, it can connect to data sources through FactoryTalk links. So if you have an old controller like PLC5, SLC 500, ControlLogix, it can also connect to Ethernet IP through smart objects. It does require Logix version 28. And you can also have third-party data coming in through Kepware and generic OPC-DA. So, and OPC-UA through FactoryTalk links. So this actually expands and covers about 99% of the data that is generated in the operational side of the equation. Now, when we talk about contextualizing, what does the contextualizing mean? Well, when we talk about contextualize, it creates an information model that if you have one cell, how it's laid out within your factory, within your plant, within your operations and oil and gas side, you have a site, you have tank batteries, you have a drilling rig, then you have a drawworks motor, you have top drive, you have different components in your drilling rig. You can contextualize it from the drilling rig down to a separate unit, to a motor, to a valve, to an instrument, and have the data tied in together in a hierarchical fashion. Right? When you contextualize the data in this format, in a configured way, it reduces your time when you are pushing it out to the IoT platform. Right? You are creating a model, like here it's shown, zone 1, zone 2, what is the product, what is the batch, how it's moving to which different zones, what it needs to collect. That is just an efficient way for an operation supervisor or a production supervisor to view the data. And now, once you contextualize it and organize it properly, you send it to different platforms that are being used to look at the data. So it connects directly into ThingWorx, which is an IoT platform from PTC, and will we'll talk more about the ThingWorks platform in our next Tech Talk on August 25th. Then it also supports IoT, Azure IoT Hub and IoT Edge. So those are the IoT Hub and platform from Microsoft, and it streams the time series data along with the information model. It also connects into SQL Server. Now, let's say you do not want to go to an IoT platform directly. You want to store it for long-term analysis. It can go into a SQL table. Right. Now, what are the suggested installation footprints? So you need, like we talked about, a scalable compute module. It can go into a scalable compute module. It can go into any industrial PC with Windows OS. This software can also run on a server class system. But as we talked about today, in the beginning, the key requirement is the software to run on very close to the PLC level. So 1756 compute module, 5480 module, VersaView industrial computers that are close to on the same network as PLC are the go-to footprint. Well, when we talk about the edge gateway, now the next question comes up is, hey, this is really good. You explained the concept. What is the workflow? How do we implement it? And why? Why do we want to do that? What does it save us? Well, there are two workflows when it comes to implementing FactoryTalk Edge Gateway, right? This is the workflow where you're using just the generic data from a generic PLC. It can be third party, it can be anybody else. It can be Rockwell too, like an older PLC file. And what it does with this, it does save you 30% of time to organize the data, contextualize it, model it, and send it out to the SQL or ThingWorks or Azure, right? And what it does, it basically opens and connects to your PLC, your data generating a device or a platform. You set it up in the edge gateway, the model, and then you map it out to ThingWorks or Azure IoT or a SQL Server. Now, if you want to save more time, then you would use what we call smart objects that do come with the edge gateway software itself. So there is no additional, but the smart objects capability does come with FactoryTalk Edge Gateway. In this workflow though, you design and you are using ControlLogix L7 and L8. When you use L7 and L8 controller with Logix version 28 and above, you get this functionality of creating smart objects. And we'll talk about the smart objects next. But when you create the smart objects, you actually end up saving 80% of time in creating and deploying models. Because now you have created the model in the PLC and you are getting the data right from the source. No translation, no communication before you convert the data into model. The model is built into the controller, and from controller, it goes to the gateway, and from gateway, it goes into the IoT platform or a SQL server.
You know, Niraj, it's a really important piece. And, you know, it's funny, after being at Rockwell 13 years, you never stop learning. And some of you guys may know Alex Cherpikoff once. He said something, and sometimes what Alex said always went over my head, but what he always said is that we differentiate ourselves from Rockwell because of how we contextualize information in terms of a product. Like, we know what a pump is or a mixer is from the bottom level up to the top. So Niraj, I think what you're doing is even building upon that of Rockwell's capability to create almost a container or an object that defines a piece of equipment or an asset, so that every oven has similar things. A mixer has certain things. And that contextual element of the parameters of that thing living, not only creating in the PLC or in the PAC and going up, but then all your other software programs can interface that object as it stands without any translation. It may sound high level, but when you think about it, nobody else kind of does that the way we do. Would you agree, Niraj?
Yes, yes, absolutely, Chris. And you brought up a great point. It is actually only us who does that in that fashion at a PLC level, at a automation controller level, at a PSE, PLC level. Nobody else does that, right? And it also, it is open. So a customer and users and programmers can actually build their own smart objects. So even though we will, now we talk a lot on smart objects, I want to introduce our listeners to smart objects today. And what are smart objects? It's a really great point, Chris. We do this currently, and nobody else in the control system side does it. It is our, we are the first ones. It is a set of configuration properties that are wrapped around a logic stack, right? So you have a ControlLogix tag, and you add on the information model, the data collection model, the real-time and historical data, the attributes, and information attributes that will be coming in future. When you add that together, it creates a whole smart object. Now, what does it give? It gives the data contextualization for any applications that are above the SCADA layer, right? So when we built and the contextualization model and configure it in the logic itself, we would not have to do it anything in the gateway controllers, right? So in the edge gateway software, we do not do anything except map it out to the IIoT platform that we are looking at. So that actually reduces a lot of rework, a lot of definition changes, and a lot of headache when it comes to programming, right? It is made for a controls engineer who views the data, who knows the data that is on the plant floor or on the drilling rig operation side. Because, hey, on the drilling rig, if you want to do a top drive, then you can actually create a smart object like top drive. So when we talk about this smart objects, why it is better? Why this is a very simple representation of why it is better. You contextualize and build a model and configuration properties inside the Logix controller. And you directly then put it into the edge gateway, which will map it to IIoT platform. So what is smart objects? How they are built, right? Let's take an example, a mixer. Well, you have the Logix tag, you built an UDT, and you built a Logix tag for mixer 1, but now you want certain information tied to that mixture and what's running through. So you can see whether it's available, with the batch ID that's running through it, the operator ID, the part ID code, all that you can tie into the Logix tag. And this creates a very good information model. Right? And these are the functionalities that we would put in to contextualize this model into the edge gateway, into FactoryTalk Edge Gateway. Now, what about the data collection definition? Well, the data collection definition will tell the Logix tag to when it should trigger. This would be the trigger. This would be on change or at a particular time. The rate is how are you collecting the data? Right. So if this tag has an on change enabled, then there is an AOI that you put into this information model that will trigger an on change data collection at the edge gateway software. Then the question comes in, well, the smart objects are great, but I do not, on Studio 5000, we do not have that configurator. Guess what? The configurator comes with the FactoryTalk Edge Gateway software. You do not have to buy extra. It doesn't, there is no extra payment with it. It is included with the FactoryTalk Edge Gateway software. So with the software, it will come as a plugin for your Studio 5000 application. it links with it, and you can build the model right there. And it is compatible from version 28 plus. So you can use L7 or L8 controllers. Now, when we talk about the smart objects, that's one part of the architecture. Now, if you want to give a holistic view on the overall architecture, on how the edge gateway actually does work, right, this gives you an overall reference architecture. This is how you would implement edge gateway. Now, edge gateway as a software will reside on Scalable Compute module or on the 5480 controller, right next to the controller sitting on the plant floor. It will connect to all the Logix controller or drives through smart objects. It will connect to FactoryTalk live data. So any data that is on the FactoryTalk environment, any capture data from OPC-DA and OPC-UA from FactoryTalk links, right? It pushes out this data to the ThingWorks and to IoT Hub or to a SQL server. So there are multiple ways you can push it onto the cloud or onto on-prem or to a hybrid solution, right? An on-prem or cloud together, which is ThingWorks is a hybrid solution. Now, what is the data flow? So what is the logical flow? Well, you have controller, your drives connect to Ethernet IP. Now, this is without using the smart objects, right? This is, you can still do the same implementation without smart objects, where you would have to define the namespace, the unified namespace or the information model within the edge gateway software itself. So you can browse the tags from any of these tag providers, create your model, information model inside the edge gateway software and map it to the application, right? And then you can deploy it to the runtime. Now with the smart objects, what it does, it actually, you create your information model at the controller level and download it into the Logix runtime. So you basically are downloading it to the controller. When you download this into the controller, now you do not have to configure your gateway, your edge software on the information model or provide any kind of namespace application. You just point it to the controller and it will automatically read the smart objects from the runtime and pull that data in. So this is the benefit. This is the value. There is no browsing. There is no clicking. You connect to the controller and you go to the edge gateway configuration and you will see what all the smart objects are running inside the Logix. And then you can just map it to your IoT application or to the SQL Server tables or to Azure IoT Hub. And this is the key value here. It makes it so much easier to deploy an IoT application, right? So again, we come back to the same workflow, right? It creates a smart object, you sync with the smart objects and gateway, and you map this model to an IoT application like ThingWorks or SQL, Azure IoT Hub. And this is where you have maximum amount of time savings total, right? You save about 90% of time when it comes to deploying an application that requires you programming in Python, Java, or learning about JSON. All those implementation trial and error, we automate that to provide you a very simple tool to achieve the IoT platform implementation. Yeah. And when we talk about this, this is one of the things where everybody has questioned. Well, I understand that you are bringing this in, and this is, but where have you used it? And this looks really nice. This looks really good. We can definitely have it. But how do we know it can be trusted? Or where have you used it? Does it work really? Well, we have implemented this in our own manufacturing line, right? We have a contactor manufacturing up in Mequon and also in Twinsburg, where we have implemented this exact product in the exact same fashion with smart objects. In the PLC, we define smart objects. You can see the screenshot here. And the trigger logic is based on machine state change. And it's creating real-time transaction management. Now, whenever the machine changes, it sends the data out on change to the edge gateway. And there is this data store and forward enabled in the edge gateway also, right? And it will populate the ThingWorks IIoT platform with the data visualization platform built into it. So all the dashboard machine learning that is implemented at an IoT level looks at the data model, the information model that has been built out from your smart objects. And again, you can also use the same model to calculate OEE. So you can see here, when you click on a specific cookie line tag, it basically information will populate the correct data into it. And this is really critical because now your OEE data is directly coming in from PLC without you having to sort through and program it inside an application, right? You are defining the OEE data points in your smart objects, and it populates the dashboard. And so in the end, I want to talk about key takeaways of Scalable Compute and Edge Gateway. Right? What a combined solution provides to any of the customers looking to implement a cloud solution. Or simplification, right? It creates an optimized solution by creating models and keeping it very tight and close-knit at a controller level. It provides the reduction in footprint that requires a lot of service, a lot of resources to integrate a data from a PLC to an IoT hub to an IoT platform. It also can capture data, right? The whole solution. The solution is FactoryTalk Edge Gateway on a Scalable Compute module or on a 5480 controller together creates a device, a solution that is capable of capturing data from 99% of data sources on the floor, on the automation world, and on an operational world into a common database through an information model. And then it can carry that model all the way to an IIoT platform. It can integrate, it can also build, it can integrate with and use the data from legacy or even third-party field devices and can work with different IT protocols. It is also sustainable in the long term because we have really good lifecycle management of this solution and how it integrates with our MES and other IIoT platform and other legacy applications. And it also, one of the biggest benefit is it provides the one version of truth, right? The application and in all the information to an application is stored in one place, one location. And from there, it can be distributed to multiple data sources, data consumers. So it can be distributed to multiple data consumers, right? It can be a database, it can be an IIoT platform, it can be another IoT hub. Okay. These are, and I think with that, I would like to end and thank you for everybody attending. But if there are any questions, please let me know and we can answer any questions that have been put into the chat.